So how's everybody doing? So this session is going to be about C# async. To give you an idea of what async is, we can contrast that with synchronous programming. In synchronous programming, you do your instructions one step at a time, and you wait for things to get done. However, with asynchronous programming, what you do is you make a call, and it goes out and does something. Meanwhile, control returns to your program, and you continue operating. The user can still interact with the program while something's going on in the background. And later on, it comes back and notifies you. Sometimes it's not all in one where it goes and does everything and comes back. Sometimes it goes and gets a chunk, and then you see updates on the screen incrementally as you do your async programming. But I'm going to cover several things here today, and mostly with the focus on what you can do with async. I'll start off with some basic async syntax, showing you the new contextual keywords of async and await so that you can get an idea about what that syntax looks like. And you've probably seen some from the keynote today. I'm also going to talk about the consumer side of the equation. When you're actually writing code, you're going to be consuming somebody else's library. And I've got a few demos on that. And I'm also going to talk about the library writing side, because you're going to be writing your own code, and there are some very important things you need to know to help you write effective libraries. And in between there, I'm going to talk about threads. And really, that's the question on a lot of people's mind is really what's happening to the thread. So I'm going to cover that, and I'm going to not only list the thread interactions on how it works, but I'm going to explain really what's important to you and to tie that in with library writing code. But first, let's talk about why async is important. You have two main focuses in mobile. One is to get a better user experience, and another is to give you a better developer experience where you can write code that's very easy to maintain. The user experience can't be overstated, because when you think about user experience, you think about things like layout and colors and maybe navigation and things like that. But also, you should think about responsiveness. I'm sure you've used the type of apps where a user will hit a button or something, and then they sit and wait for a response. And then the response finally comes back. Well, that's not a very user-friendly way to write code. So async helps you to write code that gives your users a better experience. This quote from Merrick, he gave a presentation last year on this, really exemplifies the benefit of async to the developer. Think about how you may have written async code before. When .NET first came around, we had this asynchronous programming model. And you would start something off with a begin and then have an end, and you had code all over the place, and it was hard to maintain. Eventually, we would get something called event-based async programming, and then that evolved into the task parallel library that a lot of you may be using today. And task parallel library made things a whole lot easier to work with, but it still doesn't capture the essence of the new async code. And what's the big deal about that is that not only is it easy to write, but it's easy to read and maintain. So I've got a very small snippet of what an async method might look like. We start off with this async contextual keyword. It's a modifier, and it modifies a method that can contain awaits. This task is the return type of the method. Now, return types that async, you can modify an async method with are task of t result, or void. I'll talk more about the avoid case later and why that's not such a good idea. And then you have an await. What await does is essentially it pauses the program right there while that task executes. And I'm going to show you later on what happens to the thread and what happens when it actually pauses. What happens to this thread or a secondary thread, and so on. But that's the basic syntax. Now you can pretty much use async code anywhere, but here's some of the restrictions you have, like constructors and main methods and unsafe code blocks. The new C#6 specification will allow wait on catch and finally blocks. And if you've ever tried to do an async logging function in a catch block, then you'll know how nice this change is going to be. With async, you can handle exceptions well. With the previous programming models for trying to run async code, this was not necessarily very easy to do. But now, you can put a try-catch block around an await, and it will work just like synchronous code. This task that you get back from a method, that'll hold the exception, and that's what enables you to be able to have a catch block around there. One very important point that I'm mentioning here is that you can't catch exceptions with async void. I'll have a demo on that later, but I'm mentioning it over and over again because it's one of the problems that people often have. So now let's look at some code. So I've got this program right here, and what it does is it just lets you run some async code and show some progress interactively on the screen. And that'll come up in a minute. But what it does, it demonstrates how the user can have interaction with your program while you're still doing something in the background. So right here, I have a simple start button. And when I click that, I'm getting updates. It's interactive. Along the way, I can hit the stop button, get a little activity indicator, and then I've stopped. I've canceled that operation. So you see, you can maintain interactivity with many different ways by using async code. So let's look at that code. Here I'm using Xamarin Forms, and I've got this interaction view model. It has a couple commands. The start async is when I hit the start button. The stop async is when I hit the stop button. In this start async method, notice that I'm using this async modifier, and here I am using the void. Well, that's the purpose of void for event handlers and callbacks and commands. Now inside of this code, I'm setting up some information here, but here's the async await command. So it's going to await this method right here. And when I go down in that method, this method is also async. And inside of there, I do an await. And this is showing a pattern. If you're using async, it's async all the way down. I've heard people refer to it as a zombie virus, but I prefer another description that I've heard people use. It's turtles all the way down. So I do that, and then I call this async method, and I await that. And while I'm doing this, let me show you how I did this interactive progress. If we go back up here to the view model, I set up this progress object. And notice that it's a progress. That's in the Mono framework. And I gave it this object called a progress report. And this is an object I defined myself so that I can show % and a description on the screen. That's where you saw the updates coming from. And I said when I set up that object, I gave it a callback right here, which is a lambda. And I set these properties right here that I have bound to my Xamarin Forms, properties that bind to my Xamarin Forms controls. And then down in this call async API method, I iterate right here in this for loop. And as I go along, I'm reporting progress right there. And so I just do report, progress report. It calls that progress report. Inside of that progress report, it marshals the thread back onto the UI so that I don't lock up my UI. Similarly here, I have a cancellation option. I have this object up here. It's an instance field called the cancellation token source. This is the source of where you can cancel multiple things. I instantiate it when I start my method. But down here in stop, I call cancel on the token source. What that does is, notice that in my call API, I've got this second parameter where I pass in that token to the cancellation source. So you can pass these tokens to any method or down any number of levels that you want throughout your code to get it to cancel. And then over here in my call API async, then I watch for this cancellation. I can look at that cancellation token that was passed in and say, is canceled, and then throw a canceled operation canceled exception. Or I could just call this, throw if cancellation requested, which does that for me. In the calling code, here's how that exception is handled. I just put it in a try-catch block. Operation canceled exception, and then I do whatever I need on my UI. So it's really just that easy. So when you're writing this code, you're going to consume a lot of libraries. And I've got some examples of where you can use async. And if you're looking through this list, you can say, well, that's pretty much everywhere. Yeah, it is. You saw that example where I used Xamarin Forms, but Xamarin Forms has some built-in support for async, specifically through navigation, and you can await the progress indicator also to update that. I put HTTP client up here because that's one of the perfect examples of when you want to use async, when you want to communicate across the internet to a web API or a REST service. Because what that does is that's a long-running operation that has latency. So you go in and you make that call asynchronously while it doesn't block your UI for you. So you can use async with Xamarin, Android, iOS, and all kinds of devices like Glass and Wear and Watch. And why that's excellent is because you can offload a lot of your work onto a web API somewhere on the web, and you can use these devices with limited capability to be able to add more power to your application and not lock up your UI and give the user a nice experience. This last part I had about third-party libraries, this is important because Xamarin recently opened a strategic relationship with Microsoft, and Microsoft opened up their PCL libraries. So now you have the power of all of these NuGet packages that you could never bring into your Xamarin apps before. And those are available. Many of them are beginning to use async. A lot of them already do. There's also the Xamarin Component Store and other open source libraries. By the way, right after the keynote, I went down to the IBM booth and talked to them, and then went and looked at their code. And they're using async in a lot of their libraries too. Like I said, a really good place to use async is in web APIs when you're doing like social media like Twitter or Facebook or whatever. And you can also create your own APIs where you can communicate to those asynchronously over the web. Another good place for using async is on your device, but out of process. Think about using near-field communications, NFC, or Bluetooth, or even interacting with your camera or other features of your device. Well, those things may take time to process and everything, so async is an excellent alternative there. Now I had to think a little bit about this next slide before I put it up and everything, because when async first came out, one of the things that people were saying is that, well, async is different from concurrency. And yes, it is. I agree with that. But async is an interface. You can say async, await, and on the other side of that method that you call with await, you can pretty much do anything that you want. Well, some of the early guidance was to say, well, if you're going out of process or something like these perfect examples that I gave you, use async, and if you're doing concurrency, use something like TPL. But I personally don't see any reason why you can't put an async interface on a concurrent operation. Maybe if you don't want to confuse your users, you might want to document it more. But you could have some kind of data mapping, some type of searching operation, or something else that you want to make your code a little bit easier to maintain and readable from your UI. So let me do another demo and show you some of these options. So I've got this Navigate in Progress project right here. And what it is I have two pages. I have a main page XAML and a progress page. And over on this main page, I have this button clicked async, so I'm not using MVVM on this one. I'm just capturing the event. But Xamarin has this navigation service that's part of Xamarin Forms. And to navigate to another page, you can call await on push async, giving it an instance of the page that you want to go to. Similarly, if I'm over here on the progress page, I can say navigation pop async to go back to the previous page. So it works like a stack, and it's async. Another feature of Xamarin Forms is the progress bar, progress indicator. And you can await the progress too. So progress 2 is interesting because it returns a task. And so you can await anything that returns task. Now I've been gushing so much about web APIs that I need to actually put one in here. So I've got a web API class right here, and it has a controller with values in it. You know, there's nothing special about that because you can really call any web API that you want. And here I've got a URL with my local IP address. And that's important to remember. When you're running the emulator doesn't recognize localhost. So you need to use an IP address of where that web API is residing. But I just call await client get string async, and this is using the HTTP client library that I pulled down from NuGet from Microsoft. And that's as easy as it is. let me show you another bit of code that I did not too long ago. This is using Google Glass. And so I've got this open source library that I'm going to show you a little bit more about. It's called Link to Twitter. But here's the preparation and setting up Link to Twitter. I've got my credentials. And by the way, please don't steal my secrets. But I'm authorizing, I say await authorize async, because that's going out and making OAuth calls across the internet. And then down here, I've got a query in Link where I'm using this await on the singular default async. So you can do this anywhere. You can do it on Glass, on Where. When Watch comes out, you'll be able to do it there too. Now, I've been talking a lot about what happens with async. It gives you a responsive UI. So now I'm going to talk about how it does that, because there's some very intricate things about threads that you need to know that will help you do this. Generally, you just call the async API. You just await it. Boom, you get a result back in normal development. But I want to point out some problems that you might encounter and some gotchas. So the question, what happens to the thread? Well, think of async as an interface. It's those two contextual keywords, the async and await. And when you await, you're awaiting on the task returned from the method. Well, that method, that implementation is down in a library somewhere. And whoever wrote that library, they determine what happens with the thread. They may come back and they may document it and everything if there's something that you should really know. But generally, you don't know. You could, await another async operation. It could call task run, task completion source, queue user work item. There's all kinds of ways to run the code. And so you really won't know what's happening on that side of the library. But one important thing that you need to know is, well, how does async await work with the UI? Well, one of the good things about using it is that you don't have to worry about marshaling the thread back onto your UI, because it does that for you. And the way it does this is through this feature called the synchronization context. Now, each of these technologies have some kind of dispatch or some kind of lookup and everything that's specific to the UI. And synchronization context is an abstraction on top of that. It's a common abstraction, so that you can just use synchronization context post. Most of the time, you don't have to do that, because when you put that await in your code, you await something, the C# compiler generates a lot of code behind the scenes to make sure that everything comes back like you need to, with exceptions and also UI processing. So the process of marshalling is taking execution from one thread to another. So behind the code on this await, it's marshalling that code back onto the UI thread if you need to. So that's another convenience for you. So that's what you want to happen on the client, because on the client, you want that thread back onto the UI, so that, because you can't communicate with your controls unless you do. You don't want to lock up your UI. But on the library, if you're writing a library, you don't want it marshalling code back onto the thread that it came from, because you could run into deadlock. And I'm going to show you how that happens. Now, over here, I have this project called threading, and I'm going to step you through a few scenarios so that you can understand what's happening with that thread. And I've got three scenarios I'm going to cover right here. The first one, I want to show you that async and await doesn't necessarily put you on a secondary thread. It doesn't take you off the thread that you came from. In another scenario, I'm going to show you, well, one of the ways that you can move control off the UI thread to execute something else. And then I'm going to show you another common way that you can use, that you should use in your library code, that explicitly makes sure that your code doesn't run on the UI thread. So let's look at this first one. So notice right here that see the system threading thread, current managed thread ID is 1. So that's the UI thread. I'm going to step into this code. And now, notice that I'm on the same thread. I awaited that method, and then I stepped into it, I'm on the same thread. So there's not any magical operation that's causing the execution of this code to run on another thread. So let me step down into it again. Again, I'm still on the same thread. So really, that's the point of it all. Async is not launching a separate thread for you. It's going to stay on the same thread. And not only that, since I'm on the same thread, you could have code running prior to you calling await. You can have something that sets up, the call or whatever you need. Now think about this. You're running on one thread. You're on the UI thread. You want to make sure that anything you put in your methods before you await is very fast, because by going down through your entire call chain, this async is kind of like helping performance, but you could kill performance. It would die of 1,000 cuts, where you've got these little tiny things going on all the way down. So you want to be very efficient before you call your await method. While we're talking about efficiency, notice this task from result. That's part of the TPL, and it's used in situations like you've got a cache, and you check your cache before you go out over the internet looking for something. And if it's in the cache, you just return it right away. That code that this state machine that the await generates, that the C# compiler generates for the await, it has an optimization where if you make that call to that task, before you await it, if that call is already complete, it will return and run the method synchronously after that. So that's an optimization that you get there. If it doesn't complete right away, then it's going to go ahead and go through the state machine and run asynchronously. So that was that. This next situation, I'm going to show you how to launch this execution on a separate thread. So we're running on the UI thread right here. And I'm going to put a breakpoint right there and right there. And I'm going to let this run. And notice when we're hitting this, this execution, this statement inside of the task run, notice now that, yeah, that's running on a thread pull thread, as you would expect. Now when I came back, after that, this is running on the UI thread. So you see, what it's doing is, sure, we awaited task run, but it makes sure that when you come back, it marshals that call back onto the same thread that you were on. And in this case, it's the UI thread. In this next example, I'm going to show you how to take results off the UI thread. this configure await method right here. Let me step into here. I'm on the UI thread right now. I'm going to step in and see this call. I've got configure await second level, and then I've got a call to configure await, and I set it to false. False means to take the execution of this code off of the UI thread. True means leave it on, and the default is true. But watch what happens when I step in here. This method itself is running on the UI thread, but when I come back, so this is the UI thread coming back. When I awaited that, it let the UI thread return to the caller. But now let me hit F5 and let this run so I can hit that breakpoint. Now, after this configure await was called, down here, I'm running on a thread pull thread. So configure await is another way for you to tell your library function to execute on another thread. So let me let that finish executing. Okay, so that's a basic behavior of your threads. But as I was talking about with configure await, that's a good thing for libraries. So let's talk about libraries, building libraries. One of the things I'm going to talk about is Link to Twitter. That's my open source project. And I recently took that within the last year or so and turned it into an async library. I've been building this for a while. And the first version, it just blocked the UI. I just let the caller do whatever they needed to for async. But I've been wanting to, it's been running on Mono for a while, but I've been wanting to get it over on Xamarin's platform for a while. And so what enabled that was a couple different things. It was the fact that I could use Microsoft's PCL libraries. So they have PCLs. I could use those PCLs with Xamarin. And the fact that Xamarin started supporting async. So I was able to take this library and just port it. And now it's running great. I've got blog posts on my blog where I'm using this. But I'm going to take this library and I'm going to show you some of the old code and how horrendous it was and how that's greatly improved with async. I'm also going to talk about some infamous gotchas, like things that will make your system crash and things that will deadlock your code. And that's why I went through the threading and the synchronization context and everything, because those things start to come into focus in these scenarios. Async void is for event handlers, callbacks. You saw me using it in a command when I did Xamarin Forms. You should avoid it otherwise. And the main reason is that if you get an exception in your code, it will crash. You can't await a void. You can avoid task. You can await task and task of T, and because that task that you've awaited, it holds the exception. But with void, it could run just fine for a while, and then when you deploy it to the App Store and everything, it starts crashing on people. You just won't know it. Another problem when you're running async code is using wait or result on the task. You can say task wait, but you really don't want to do that. Task wait is not the same as an await. Task wait is synchronous. It's a synchronous wait, and the problem with that is that it blocks the thread it's on. It blocks a UI thread. Same thing with result. And when you're blocking the UI thread, then you can get a deadlock because you're blocking the UI thread. And also, you want to use configure await in your library to avoid these types of situations. This 50 milliseconds is a benchmark that Microsoft decided to use when they started building async libraries. They said anything that's greater than 50 milliseconds, we're going to make async. If you don't want to do your own research to find out what that threshold is for you, then this is probably pretty good because they've done those studies. But also because when you start taking a library that might be synchronous and making it async, you don't want to, it costs time and money. And so you don't want to just boil the ocean and make everything async. Nor should you make everything async. Async's primary benefit is when you're doing something out of process or via across the internet. If you have parts of your API that are not doing something like this, then it's better to leave them as synchronous calls because then you don't have the overhead of the async. That wait command that the C# compiler translates into a state machine, well, there's overhead in it. There isn't a whole lot of overhead, and it's certainly probably a whole lot more efficient than I could do myself, or many of us. But you've got some design decisions to make based on what the benefit is of going with async and the efficiencies of not doing it for something that's going to be slower because of the overhead associated with it. So I have another demo for you. And this time, I want to go to the old link to Twitter. So link to Twitter is a link provider that works with the Twitter API. And these days it's async. But before it was async, I had methods like this, query Twitter. It would go out and do the query. And here I'm setting things up, and everything's nice. But notice how I've got a try block right here. And not only do I have a try block, before the age of PCLs, I had all these pre-processing directives and everything. It was just really cumbersome to work with. But I've got a try block to catch exceptions. I've got this request object, and now I'm using this asynchronous programming model, APM. And the reason I had to use that was because I wanted to support .NET 3.5, and TPL was not available for that. So I've lived with this code for a long time. But anyway, I've got this callback, and down inside the callback, I'm trying to capture this experience of being able to look at my code at one time. So these lambdas are helpful. But now I've got all of this code in here doing something. I'm catching an async callback, and I'm keeping track of the fact that an exception was thrown. And then I've got this finally where I'm looking at that callback and so on. And you can see right now that this is really cumbersome. Every time I had a bug in this code, I just dreaded going back into it every time. And if I go down here, you'll see some more of this code is just repeated all over the place, and it's really uncomfortable. So now let me show you how it's improved. Now here's query Twitter async. And notice that it's async and returns a task of string. And see how the method's much shorter? And instead of all those begin ends and weird catches, I got extra try catches in there, I've got that one call that replaces all of that. And you see the fact, I'm not going to catch an exception in here because I have a library. And what I want to do is I want these exceptions to flow back to the user so that they can make that decision. So I don't even have to put that in there. And it's pretty obvious which code would you rather maintain? Which code would you rather write in the first place? So this is a really huge benefit for the user. Again, you can see where I've got a single await statement. I await that, it comes back, and instead of trying to figure out how to build a continuation, I just got it's going down after it comes back from that await, and then it goes to the next await. and I've got everything. It looks like synchronous code, and it's so easy to work with. Now I have a couple other demos that I want to show you. So let's go look at that async void code. So here's an example of an async void method. Okay, so here's the event handler. Okay, it's got to be async void. But I call this void first level, and notice that I'm not awaiting it. You can't await it. You can't await void. It's not a type. And then I've got this void first level right here. That's async void. And I'm going in here, and I'm throwing an invalid operation exception. And even though I got this in a try-catch block, this will never be called. And then it's going to go off, and it's going to crash your program, and you won't know why. So here's how you fix it. Task is when you don't need to return a value. If you need to return a value, use task of tResult. And then here I can await it. And then here, this will be called. Now it's fixed. So in addition to void, another infamous gotcha is deadlocking your UI. Remember that wait I told you about? That's a synchronous wait. When you hit that wait, it blocks right there. It blocks that UI thread. Now, it calls this method. This method executes and returns. And when this returns, it's trying to marshal the call back onto the UI thread. But that's the problem. Wait has the UI thread blocked, and so you have a deadlock. So that was all of my demos and code and everything. But let me summarize. One of the reasons you want to use async is, number one, for a great user experience so that they can have a responsive application. But also another reason is so that you can have a good development experience and make your code more maintainable. We talked about the client experience. You can pretty much use async anywhere on any device, and libraries are coming out with it all the time. And I also talked about the threading model, where async does not necessarily change your threads for you. You have to do something to explicitly do that. In the client, you want that marshaling back on the UI so that you can access your controls and bind to your properties that update your Xamarin Forms control too. But also, you got to watch out. You can watch out for async void. You know, just don't use it unless it's something that it's intended for, like event handlers. And don't block the UI thread with wait, and don't put anything in your UI thread that's going to slow your program down before you do an await. And when you're building libraries, always remember to use configure await, because that's best practice. So that concludes my talk, and thank you for coming, and I hope you all enjoyed the Xamarin Evolve 2014 conference.